part of the teaching assistant for the ML and AI track, and I'll be taking you guys for today. So before I move on, I want to know how the course has been for you guys so far. Like, have you been able to catch up with it? Do you understand what you've been learning so far? Hello, you can talk if you want to. Raise your
Okay.
hand.
Yeah, sorry, can I say something? Yeah, I want to like okay, so far, right, we've done classification under machine learning, we've done regression, we've done linear regression. I think we've done logistic regression. I'm not sure. Either linear or logistic regression. We've done multiple regression. So that's under supervised learning. Then we went to unsupervised and we did k-means clustering. Yeah, we did k-means clustering, and I think we did um, dimensionality reduction, like reducing dimension and all of those things. So far, that's what we've done, and I think it's been 2 months now. Yeah, so that's what we've done. So for the assignments of courses I think courses to do, we haven't really gotten one since the last one that we've done. So we are still expecting to be assigned courses, and yeah, but yeah, so far that's what we've done, and we just don't know what's the next step now since no courses have been assigned to us.
Sorry,
Thank you.
sorry. Can you go back again? I didn't hear that part. You said you haven't what?
Yeah, I said we haven't been assigned because I don't know, Mr. Dixon, I think he assigns courses to us like on a weekly basis, right? Like I think we'll have like 6 days to finish maybe 1 or 2 courses at a go. But since the last one, I think the last one was on I think I can't even remember. I think it was on XG Boost, right? Yes, it was on XG Boost and pre-processing under the machine learning scientist track. That was the last one that we've had, and we've not had any since then. It's like I think like almost a week ago that it has been due. We haven't had one to do. Although I mean, like some people still have pending assignments that they have to reassign to them, so they can do it again and they can move on from that. But new ones entirely we haven't, and they really haven't been timely enough. So that's the issue that I'm having. I don't know if you heard that.
Yeah, I get that. I get that. So I was actually reached out to them because I cannot assign assignments to you guys. It's the same way that it's the only one I have access to assign assignments to you guys. But I think he has been really busy. So that's the major reason why he did not assign tasks to you. But aside that, um let's just move on, right? I'll make sure that you guys get your assignments for this week. So you have something to do and move on with. I'm really glad that um few of you are here, like it's fine. Today, let's just go straight right into it. I'll be talking about feature engineering. Which of you are familiar with feature engineering? You can react, like you don't have to talk. I just want it to be interactive to know that we are all playing together. Oh, nice, nice. So I'm actually going to dive a bit deeper into it. And that's what we'll be doing for today. So I'm not at home like in a conducive environment. That's why like you guys were able to hear me at first. I needed to move away and I will not be able to take much time. So we'll probably spend like less than an hour or maybe an hour and we finish up. Um yeah. So let me just dive into what I'm supposed to start. So what is feature engineering? You guys have heard the word feature. Like feature is something that is very, very important when it comes to your data set. Now, what are these features? Features are let's say for example, when you look at a person has features, attributes. Now, what are those features? The person has an age, the person has um class, the person has like height, the person has width, the person has like let's just say um the person has home address and all that thing, a phone number. Those are features of the person. Now, these features are the things we use most times to um are the things we use most times to train our data. And the feature can range from two, three, four to even thousands, like, or hundreds sometimes. It just depends on what kind of data you are working with. So yeah, I'm just like giving you guys a very like real life analogy of what picture is. So now let's go into what engineering is. Now, I would actually like uh someone to, if you have an idea of what engineering is, can you please just unmute your mic and tell us what you think engineering is?
Hello, sir.
Yeah,
May I continue?
yeah, you can go ahead.
So,
But okay, go ahead.
in my own understanding, feature engineering deals with scrutinizing which features matters the most and which features doesn't. So, some features carry more weight than others. So, we select the best ones that are good for our model and discard the ones that doesn't make any impact. That is feature engineering.
Oh, thank you very much for that. I really, really agree with you on that, and you are very, very correct. Um, yeah. So what this helps to do basically, it improves your machine learning model. When you train models, you don't just train models. Like, data collection is like one of the most important parts um of machine learning. And if your data is like bad, or like they say, garbage in, garbage out. Like, what you give it is what you get, and if you give it rubbish, you get rubbish. So it's always good that we are able to engineer our features in such a way that it's very useful for us, very useful to be able to make our model perform very well. Now, there are so many types of data we have, and because a lot of times, like, what matters in features and feature engineering is that we are dealing with data, and we have different types of data. Now, this data can be continuous, categorical, ordinal, boolean, or even data type. Now, if you look at this, let's look at like few of this that I just mentioned. So let's start with the categorical. We all know like what categorical is. So basically, categorical is like saying black, white, red, blue. That's like categorical features. Now, a lot of these features are written in text, and but there's the correlation, right? They are all colors, but then different type of colors. So they are in a particular category of colors, and that is the data or a feature of that data set. Now, let's look at another one, which is Boolean. A data can either be true or false, right? That's another type of feature or type of data rather. And then we have the data type. Data type is kind of like tricky because it has like this typing sometimes, and then it has like strings of numbers that we need to make sure that our computer understands what that number is. That is where feature engineering comes out. That is why it's important for us to understand feature engineering. It helps us to be able to convert our raw data into um, features that are very useful for us. So let me just give you guys like a very more accurate description of what feature engineering is. So I already discussed on, someone already told us what feature engineering is. I already discussed on what features is. I already discussed how feature engineering can help improve our machine learning model. And I also talked about um, what feature has basically is data, and what types of data it has. There are so many. Now, feature engineering is the process of turning raw data. Now, when I mean raw data, I already mentioned some of this raw data, like continuous, categorical, ordinal, data type. Now, you take this raw data and then it turns it into features that helps improve the performance of our machine learning models. And now, most of the time, it has to do with adjusting it, converting it, right, to be more accurate and give us a much more better prediction. Um, so basically, before you start feature engineering, or when you want to engineer your features to make sure that it is useful for your data. We need to know our data first. So I think I would have to share my screen. So I'm just going to give you guys a bit of project that I have done. For it might be a bit complex, but we're not going to go into complex parts. You guys will just try to get where I'm going with what I'm trying to explain. So I'll be sharing my screen on a particular project I worked on recently. Yeah, can you guys see my screen? Please, if you can see my screen, just react. Oh, nice. Nice. Thank you very much for that. Now we can all move on. So, yeah. So now this is a data set based on e-sign. It's like predicting how often people sign on an like you go to work and then you need to sign that you're already in work and stuff like that. So this is like a data set collected on that kind of picture. So most times first thing you do when you're working with data is you need to import your data, which is this particular place. Can you guys see the place I highlighted? If you can, please react. Oh, nice. So like every machine learning project starts, we start with importing our data. Now, why are we importing we need to that's the data we are working with. Now, when you import your data, you need to know what our data contains, like what kind of features does it contain. Now, these dependencies basically help us to be able to use it to um, import our data and do some basic like arithmetic or like coding with it. Yeah, let's just go on. So from this data, we can see that we have entry ID, age, pay schedule, homeowner, income, month employed, years employed, current address, personal account monthly, personal account yearly, amounts requested. We just have like so many data. And this head is just basically saying, oh, what does this data contain? Oh, sorry about that too. Okay, it's back on. So yeah, I'm just trying to check what data I have and what kind of feature it has. That's why I did esign.net. Then we go into seeing, okay, what kind of information does this data contain? Now, this data is a pandas data frame, basically, and these are these are all the features it contains, right? These are all the features it contains. Now, I would like to ask you guys a question. What do you think our target feature is, or what do you think we are trying to predict here? Out of all these features here, which of them is like the one we are trying to predict? If you know, you can just drop it in the chat, or you can talk or mute your mic and talk. And e-sign, nice. Thank you very much for that, Grace. Yeah, e-sign is the target feature. This is what we are trying to predict. Now, to be able to predict this, we need to make sure that whatever feature we are having here is actually useful to us. That is feature engineering comes in. But before we go ahead, we need to get to know our data even better. Then we do esign.describe. What does this dot describe do is it basically give you the mathematical summary of what your data contains. Now, how many data does entry ID contains? How many data does age contains? That's what counts does. It just counts the amount of data each of these features contains. And from the look of it, most of them contain the same amount of features, 117,908, as you guys can see. Now, the second part is the mean, the standard deviation, the mean, which is like the lowest number each of these features have, and then we have the quarter range, interquarter range, and then third quarter range, and then we have the maximum value each of them have. Now, the next thing for us to do is we need to split our data. Now, when you're working with feature engineering, the reason why it is important for us to split our data is because sometimes our test is what we want to use to make sure that the model we create is actually working accurately. So when we train some part of our data, we are basically training the model to understand what kind of data we are working with. And then when it sees that same data somewhere else, which is our test, it can be able to perform well. Now, I split the data by importing scikit-learn model selection, and then from scikit-learn model selection, I imported the test trace. Then I selected the E sign, which is the target feature. That's what we are trying to predict. That's our Y. Then our X is like the remaining other features. Now, what does drop do? Drop just takes out a particular feature or a column that we don't need in a particular place. So yeah, our test set is just 20%, and our train set is 80%. Now I set random state to 42 so that I can have constant a constant output of what the X train, X test, Y train, Y test have. Unless I'll just be getting random numbers. So now from this, we need to like go on and check if we have missing data. So this other part, in case you were wondering why I just scrolled out, I'm just like checking if my X train is there, and I can find it, which is here. And then I had to check the description of the X train. Now you need to check for missing value. You need to check if any of the data has missing value. Now, from the looks of most of them have no missing. If they have missing value, you see the amount of missing value they have. And now from this, we have entry ID, age, pay schedule, homeowner, income, month employed, years employed. Those are the features, and none of them have missing value. Now, I've gotten into the technical part of feature engineering, so you guys should actually listen carefully. And this is one of the first steps to take. You check your data, you know your data, which I've explained. You select the data you want to use, which I've explained that you have to start with the training set. And now we are dealing with missing values. Now we are trying to check if any of our features have missing value. Now, when a particular feature has a missing value, there's a way to go about it. And one way to do it is either you take out that particular color if it's not useful for you, or you replace each of those missing values with a common value in that particular column or feature, or you just replace it with a 0 or the mean, depending on the kind of data type that column has. It can be a categorical value, it can be numerical, it can be date, it can be ordinal. So you need to always take note of those things. That was why I started with types of data before we dive in deeper. So before I continue, I would like to know you guys are following me. So you can just react or send the message or something. Yeah. Oh, nice. So I also like to know if you understand what I've been saying. Oh, perfect. Great. Yeah. All right. Now let's go back to the project. So I've already talked about like missing values, and from here we don't have any missing value. So the next thing I did is I tried to check for categorical variables or categorical values. Now, what this code here does basically is that it checks for any feature that has categorical value. And from what we've seen here, we can see that only pay schedule has categorical value. And from the data here, we can see that, oh no, I've gone back here. Sorry, it's a mistake from my part. All right, let's go back. All right, so from here we can see that pay schedule has something like bi-weekly, monthly, and it also has other stuff there too, which are not here because I just printed the first five rows of the data, which is like putting the data frame dot head. You all should understand that one by now. So yeah, let's just move on. So I tried to check for the categorical values and I discovered that only pay schedule has categorical values. Now I go to the next part, which is to check for numerical values, numerical features rather. We're still going to deal with how to handle these categorical values, and then we'll deal with how to handle the numerical values. But let's just move on. So from here, we can discuss. So what I just did here basically is I selected any feature that has numerical values using this code here, which is like CNAME. CNAME is the variable I just defined here. So for every CNAME in xtrain.column, which is our data frame, that's like saying data frame dot column, if xtrain CNAME dot type is int 64 or float 64, you know, int and float are both numerical values. Int is an integer, while float is the decimal number. Int is more like whole number, like 1, 2, 3, 64. While float is like 64.2, 1.0, 10 plus 10.000 and all that. So from here, we can see that majority of the values we have are actually numerical. So luckily for you guys, this is a very simple dummy data we are working with. So it means that it wouldn't give you so much stress. But note one thing, most real life data are not like this. Real life data, you are going to go through so much issues. And one thing that will make your work easier is feature engineering. And if you know feature engineering very well, trust me, like most of the models you'll be building, you would not even have issues with them. Because building the model is just like the last thing. But like the feature engineering is super important because what you feed it is what you get. Garbage in, garbage out. So if you feed it a bad feature, you get a bad result. But if you feed in a very good feature, you define your feature well, get a very good result. So now, what I'm doing here is I'm creating a pipeline. This is more complex for you guys, but at the end of the day, it's actually the same process you follow. But in this place, the process is just much easier. I'm creating a pipeline, and in this pipeline, I'm able to pass in each of the methods. That's like saying, okay, this particular column, I want you to do this. Then after doing this, I want you to do this. Then after doing this, I want you to do this. Do you get? Instead of you writing the code one by one, you just write it all at once, and then it just does it in a pipeline. Let's think of it like instead of you trying to fetch water and carrying it on your head to your house, you can just on your tap, and then the water is coming from the tank directly into your house. Do you get what I'm saying now? Please, if you get, can you just react? Oh, nice. I'm so glad that you guys are really following up. And yeah, that's beautiful. Yeah. So now, like I was saying, we created a pipeline. Now, what are the things I did? I imported some very important dependencies. Now, before I move on, I'm just going to start with the most easiest one, the numerical data. Now, when you want to process numerical data, we use what's called simple imputer. Now, the simple imputer helps us to convert our numerical values into. Sorry. Just give me a second. Okay. So to confirm, can you guys hear me? Please just react if you can hear me. Oh, nice. Thank you for following up. So basically, what this pipeline does, like I was saying, preprocessing of numerical data. What simply imputer does, basically, it replaces missing values in a numerical feature with a median or mode or even zero or like most frequent data. Now, if you can see, we defined an attribute here called strategy, and in the strategy we have was we changed it to median. Now, most times we need to be very, very careful here when trying to give missing values, like change missing values. A lot of times, like missing values has to do with sorry. To be able to determine if we convert to mean or median, we need to know like how skewed the data, that particular column is. Unless like we might be overfitting our data, or we might like have like a bit of issues with our models. So we'll go into that one later. Let's just move on to categorical data. Now in categorical data, what this pipeline is basically doing is that it is transforming, like taking every missing value and changing it to the most frequent value in that category, and then transforming it into an array of numbers, like categorical numbers. So it's like this now. I don't know if you guys are. There's no way. How can I go? Like, is there a way I can draw? Let me try and look for, maybe there's a whiteboard or something here. So I can show you like a description of how the array would look like. There's no board here. Let's just move on. Don't worry. So basically, one of encoder. Let's say, for example, we have blue, yellow, and red. Now, blue, yellow, and red, most of these are the type of data we find in a particular feature, and that feature is called color. Are you guys like, you guys can just imagine it? That feature is called color. Now we have color, and in this color we have like random colors like blue, yellow, red. Now those are the specific colors that are there. That is a type of categorical value. Now in these categorical values, what we do with one of encoder is we try to check, let's say the first row, what color is there. Let's say, for example, red is there. Now what this does is that it checks through blue, yellow, and red, and then for anyone that is not there, it assigns 0 to it. So blue will be 0, yellow will be 0, and then red will be 1. So now what this is happening is, instead of using yellow, red, blue, green to use to train our data, we are now using a particular categorical array to train our data. Do you guys understand? Please, if you do, just react. Oh, thank you very much. Okay, let's move on. So yeah, I've explained the simple imputer, one of the encoder. Now let's go to the numerical values back. Now column transformer, what this does is it basically takes this stuff we transform, like that's the preprocessor. It's like you creating a function that helps you to preprocess your data. It transforms it and then assigns it to a column. So now this is the model I'm using to train this data. This is actually a very like advanced model, and I don't think you guys have gotten here. But this random forest classifier, what it just does is it helps to classify data into like maybe 1 or 0, or like yes or no, or true or false, that kind of thing. So we have random classifier, and it has these 2 arguments of n estimators and random states. So the metrics we are measuring this on is accuracy score, recall score, and F1 score. Why are we using these metrics? Because it's a classification problem. We are dealing with a problem of yes or no. We are dealing with a problem of, okay, is it there or not? That kind of a thing. Assuming it was a regressor problem, we would use a different matrix. Matrix like recall. Like recall, yes. No, not recall. Sorry. we use other metrics basically. I'm in a very like noisy environment. That's why I'm like shouting. So yeah, from this pipeline, this is actually a more advanced. Oh shit, I should have not used this for you guys. But anyways, what this code does is it takes our data, we process that data, and then we use that preprocessed data to predict on our test set, and then we measure the accuracy. That's why we are able to get the accuracy score, recall score, and F1 score. That's what this code does here. You guys might not understand, but as you move on, you understand. But if you do, like, you can just react. Well, I kind of doubt, except if you guys are gone far. Okay, let's just move on then. So let's move on to nah, not this part, not this part. Okay, this is the main part of the feature engineering. So what I did here basically was I tried to train the model and then find the accuracy without actually using feature engineering. And then I applied feature engineering afterwards, which is here. Now, this is a very like more technical feature engineering. This one has to do with like how you can think, like how you can look at the data and be like, oh, this data kind of looks obsolete or it kind of looks redundant. How can I make it in such a way that I don't have too much features and I'm still able to train my model to perform very well? That is where something like this comes in. Now, X-train years employed. What I'm just trying to do basically is I'm trying to take what I'm basically doing is I'm trying to take years employed and months employed, and then I'm trying to bring those two together and then put them in just no. Wait. Okay, so years employed normally what it has is like how many years like the person has been employed. This is 1, 2, 3, 4, 5. Now I needed to convert that into the amount of months, to be specific, the amount of months that the person has been working. And then I took that month. Okay, what I basically did there was I just transformed it to the amount of months. And instead of it saying something like 5, 6, we just multiplied it by 12 and then gave the new value. Let's look at the first value there so that you guys can understand. Let me just go back up. So this is the first value. And from this first value, we can see that we have years employed to be 5. Now, what I did basically at this place was I took that 5 and then I multiplied it by 12 and then I got 60. Now, what this means basically is that the person has been working for 60 months. That's just what it means. The person has been working for exactly 60 months in that place. If we take 60 and divide it by 12, we are going to get 5, which means the person has been working here for 5 months. Now, I needed to also get the months employed. Now, what this month employed now shows is the total amount of months plus the years employed I got, which I already converted to months. Then I now took the month and year and then added all of them together into one called month employed. Now that month employed is now added to the back of the data, which is here. Can you guys see it? I'll highlight it so you can see it. So we have 61. And then if we come here, we'll realize we have years employed to be 60 and months employed to be 1. And then everything in total is now 61. Please, if you are getting, can you just react? Okay, someone have a question. Don't worry, go ahead. Go ahead with your question. Go ahead with your question. Richard, you raised your hand. Okay, I guess the person does not want to ask, so I'll just move on.
Hello?
Okay, go on. Yeah, go on. I'm listening.
I understand the years employed, but I didn't follow up on the months employed. What you actually did at employed side.
Okay, I'm going to explain back again. Now, if we look at the original data set, let me scroll up so we can follow up better. If we look at the original data set, you will notice that we have months employed and we have years employed. Am I clear on that? Let me know use this. Sorry, let me just go back up. Uh, I'm trying to look for it. So. Wait, let me just look for it then. Like, why?
Okay.
Okay. Uh, okay, I'm there. Now, if you look at this place, this is the original train X-train data. And in this X-train data, we have months employed and years employed. And that's basically the data we have to know how long the person has been employed. But then it was now split into 2 months and years, which doesn't make sense because if we use this kind of data to train our model, we are not going to get a very good performance because we are having months and we are having years. That's like having redundancy. That's like tautology, having 2 things in different places said in the same way or in different ways, but it's basically the same thing. So what I'm just trying to do is I'm trying to combine it and bring it as one. So how am I bringing it as one? Instead of having years employed and months employed, now I now bring it as just months employed. That is what the code does here. Let me scroll back to it. That's what this code does here. But first, I needed to calculate the years into months, then add the converted years into months to the total amount of months. Do you get that now?
Understand now.
Okay, nice. Now let's move on. So we can now see that the total amount of months we have is now 61, which is highlighted here. Which is already highlighted here, 61 months employed. This is now a new feature I created. So I took a raw feature and then I converted it into useful feature that can help my model perform better. Now let's move on. That is just one part of it. Now I now have to drop the months employed and years employed. So this month employed and years employed that you guys see here, which is this and this, I brought it down. I dropped it, which means I don't want it again in my data. It's obsolete to me. So what I now have is just months employed. So I don't have the same data talking about the amount of time the person has been working in 2 different ways, but rather I just have it in one way. Do you guys get? If you get, just react. Nice. Let's just move on. So yeah, I needed to also convert another data. Now we have personal accounts per year, and then we also have personal accounts. That's like having personal accounts per month, which is this. Let me highlight it so you guys can see. So we have this personal accounts Y, and then we have personal accounts M. We just mean personal accounts in a year, personal accounts in a month. And we have so many numbers there. But then I just wanted to bring them into one. Now to do that, I needed to write this particular code here. So what it does is it takes the personal account yearly, multiply by 12 to get total amount of months, and then add that total amount to the other month we have, personal accounts per month. So the whole thing just gave me the total number of personal accounts, and then I added that data to the back of my data set, which is now here, telling me the total amount of months that total the personal account that the person has basically. And then I dropped the personal accounts per year and then dropped the personal account per month. Now from here, I checked my data again to see if I need to do anything. Since there's no missing value, since I have dealt with redundant features, now the next thing to do is I need to check if my data, so using histogram, you'll be able to view your data to see if they are distributed normally. And if you can see here, most data are actually distributed normally. Aside from this entry ID, which is honestly not even necessary, this is what we are focused on. And from here, we can see that some of these data are kind of not the way they are supposed to be, but majority of them are the way they are supposed to be. So, for example, this homeowner is kind of weird. It's like as if it's having an outlier, like a data that is way out of the league. And then income is actually fine. It's normally distributed. Age is also normally distributed. Current address is normally distributed. Every other thing, yeah, is very, very normally distributed. Now, you guys have not got to correlation analysis, so let's just keep that. Let's keep that. Let's keep this too. So let's just go to handling categorical values. Sorry about this whole complicated stuff. So what I'm doing here is I'm checking what kind of data my pay schedule have, which is the categorical value I have. Remember, I said categorical values are like values that have, you know, for example, colors. We have different type of colors: red, yellow, green, blue, and all that. In a data, you can just have maybe 3 random colors, and those are the only colors that exist there. Now, they are example of categorical value. Now, in this part, we have bi-weekly, we have weekly, semi-monthly, and monthly. So value count helps to take, so it helps to check our feature, look at what is similar there, tell us the total amount, and then just basically list out everything that is in a particular feature. And from what you can see here, you already see that bi-weekly we have 8,570 bi-weekly data that is there. We also have for weekly, we have semi-monthly and monthly. What I'm now trying to do here is I'm trying to convert that into something that the computer can understand. Computer only understand number, they don't understand text. So we need to convert it to text. And to be able to do that, I needed to import label encoder. This is just one way of doing it. There are other ways of doing it, which I also included here, and I already explained one already, which is one-not encoder. But aside that, let's use one-not encoder. You guys should ignore this, please. Ignore this. Just ignore it because it needs to be complex, and I don't want it to be complex for you. So let's just look at the one-not encoder. Now, for one-not encoder, what we are doing is we are fitting our data and then we are transforming it into an array of numbers that the computer understands. Now, from here, we instantiate our data, as you guys would always do with instantiating your model that you want to use. We instantiate our data, and then from instantiating it, we fit and transform the data of what we of the categorical value, right? Which is basically our pay schedule. That's what this code is saying. Don't forget about these jargons that are here, but that's what the code is saying. And we converted it into a float type, right? But it is in sparse, compressed sparse row, sparse matrix. It's in a sparse matrix, but in float form, which means it's in float form, but in sparse. Now, for you to be able to view how each of the data is, we use something like this. So this array here, which is 1000, just shows that the data we have is bi-weekly. Like this first one here is bi-weekly, this second one here is bi-weekly, this one here is bi-weekly. Now for this one here, it's showing that it is monthly, which is the last one. That's all. If you can see in each list of array, we have 4 numbers, and each of those numbers either contains 1 or 0. Now that's what this is helping the computer to understand which of them is which one is by month, which one is monthly, which one is monthly and bi-weekly also. So before I move on, I want to know that you guys are following me. So just react if you are following up. Please, I just want to ask a quick question. I hope I'm not too fast like my talking and everything. I hope you guys are like following me. And if you are behind, just let me know. So I'll just go back. All right. Thank you for your response. So let's just move on. So now, let's just move on to the next thing. Yeah. So after converting it into array, what we needed to do is we needed to scale our data. Now, what's the point of scaling? Now, when we scale data, what we are trying to do is we are trying to fit the data into a particular range of numbers. So we have different ways of scaling. We can scale using min-max, we can scale using standard scaler, and we can also scale using power transformer. But in min-max scaling, it is like saying, okay, we want each of these values to be from 0 to 1. So whatever value that a particular feature wants to have is not more going to be that initial value you have with the original data set. It's now converted into something else. That is why we are fitting it, then we are transforming it into what we want it to be. But in standard scalar, we are basically taking from, let's say, the middle, which is 0, and then minus, then upward. So like, if you guys can see, we have like some values that are here that are minus, and we have some that are just there, but most of them have like this point something, points, all that and all that. Let's just, it's just transform to something like and use to train our data. That's just what it does. So what I'm doing here is I'm creating a new data frame to help me check for the column and my transform data. So this is now the new, this is now like the data I'm now going to use to train my model for it to be able to perform better. Now, if you guys watch very well, you notice that the age is no longer maybe 12, 30, 40, 50, and all that normal number of age is supposed to be. But now it's having minus 1.597, blah, 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 0.51, blah, blah, blah. Like all this story, you don't even need to understand. The computer understands it. But you've already done your part on fitting and transforming it into, it's like you've normalized it. I'm very sure you guys are familiar with normalization. That's what we just did there. We normalize the whole data so that they can create themselves more effectively and then perform even better. So after I normalize the data, then I try to check the shape of the data to know if I'm still on track. And now what I'm doing here is we are training our data with a model, which is logistic regression model, and we are training it on the matrix of accuracy score, F1 score, precision score, recall score, and all that. And then I just copied my data so that I'll be able to have the original and then the copied one which I'm using to train. So that it's more like so that I'm able to recover the original if I want to recover it. So now that I've already worked on all my pipelines, I'm just like using this code here, basically is like taking all the stuff I've worked on so far and like bringing it into one to just like, try and train my data to work better. So yeah, the data I didn't actually finish this thing, sha. I didn't know I didn't complete it. But anyways, let's check the accuracy. Yes. Okay. Oh, right. This one is not there. This F1 score, F1 score. Okay. So now, if you guys can look at this very well, you guys can see our recall score is one. And what this means is that model is actually like kind of back, but it's performing way better than the first one. And that's because we engineered our feature to be able to thrive, and then we've normalized to be able to be the same with what every other features have, and then we use it to train our model. So I think that's majorly what I wanted to talk about. Yeah, that's majorly it. So one more thing before I move on. One more thing before I move on. Just that the codes are not here. That's why I didn't want to talk about this one. The code are not here. So yeah, let me just give a quick recap of all the things I talked about. I explained what feature engineering is. Then I explained what it contains, it's like the data types. And then I explained like how to handle some of the data types, more specifically numeric and categorical. Now, in numeric, I told you that you would have to check for missing values first, convert those missing value into something that you have more there or into a median or mode. And then I said after that, you would after converting it to after dealing with your missing data in your numeric, then what you do is you convert that numeric data into lost my train of thought there. Let's just go back to it's okay, yeah. So we convert it into something that the computer can understand. Like normalizing it or standardizing it, like using min max scaling or standard scaling or power transformer. That's after you deal with the missing value, then you standardize it or normalize it with any model you want, like maybe min max or standard scalar. And then for categorical value, you check for missing value first. Then whatever missing value is there, you just replace it with most frequent, or you replace it with not a number. But majorly it's just most frequent used to replace categorical values. And after you replace it with that, we're going to encode it to convert it into array. We convert it into array that the computer understands. Do you get? So that's it for numbers and categorical values. So that's majorly when it comes to these things. Like we take that data, we try to study our data. Then after knowing the kind of data we have, we check for missing value data. After we check for missing value, we handle the missing value by replacing it with median and it is numeric. And then if it's categorical, we replace with the most frequent. And then after doing that, we're going to standardize it. And then we fit transform it. Now, why we fit transform is basically your standardization process using the min max scalar or standard scalar. Yeah. And also we can also remove outliers. To remove outliers, that one is more complex. And I cannot explain to you guys now because I would have to like spend another 1 hour and I don't have that time like this anymore. So yeah, if you understand, please just react. If you understand, please just react. I want to show that you guys already got what I explained. Please, if you understand, just react. If you have any question, you can drop it in the chat box or you unmute your mic and talk. Okay, yes, I'll send it on the Discord channel. It can be complex to understand though, so anything you don't understand, just leave it. Or you can just ask the question on Discord, then I explain. Because I don't think you've gotten there in data cap yet. So I'm just going to give like 2 minutes. If you have any question, I'm giving like the chance of 2 minutes for anyone to ask. Attendance form. Let me check. I don't know where attendance form is. But I'll check. Let me check if there's attendance form. For the attendance form, you know what? I'm going to send it on the Discord if I see it. So I don't know if I'll see it, or I'll send this on the Discord. Well, I'll make sure that you guys get your assignment for this week. Sorry about last week. The team lead was probably very busy. Yeah. So before I go, yes, I'll send it on the WhatsApp. I'll send it on the WhatsApp. Okay. So I think I'll leave now. But before I leave, I just want to introduce myself properly. My name is Fawaz Aro Fawaz. I am part of the TA for machine learning, for the machine learning track. And you guys can always start if you need help on the Discord channel. Mr. Dixon will not really reply to you because he's very, very good. So you can always tag me if you have any question. And also, you guys should try and post your progress more. Post them on LinkedIn, post them on the Discord channel, so it can encourage others to, go further. Okay, Paul has a question.
Yeah, Fawaz, it's me. Hold on, let me get the attendance link for you shortly. Just hold on.
Okay, someone will send the attendance link to you guys now.
Please, please type your name on the chat so that we can spell your name very well.
Please, someone just talk now. I didn't get what you said.
I said you should please type your name, your full name on the chat so that we can get it very well.
Okay. No. Yeah, so while Paul is working on trying to bring attendance here, yeah, I was introducing myself earlier. My name is Fawaz Aro Fawaz. I've typed it there. You guys can see it. A machine learning scientist. And I'm also the TA for the machine learning track. I'm from Nigeria, Lagos to be more specific. I know like most of you here are from other parts of African countries. And I would really love if we can introduce ourselves. Just, say your name, talk about how the machine learning journey has been so far. And yeah, like, I just want like us to get familiar with ourselves. So anyone that wants to go first can unmute and talk, or maybe I should call. Yeah, Paul, what's up?
Yeah, I just dropped it, so just let everyone know, please.
Okay, you guys can start signing your attendance. It's already on the chat. It's on the chat. Yeah, you can if you want to, like, you can.
Okay, good afternoon, everybody, or evening, wherever your time zone is. My name is Emmanuel Ebifredrick, but Emmanuel is okay, and I'm a machine learning engineer, and I'm also a student of University of Lagos studying computer science. So I'm just running my skills, and I'm a software engineer, which goes without saying because computer science, software engineer, yeah, and that. So yeah, thank you.
Thank you for that one, Manuel. That's a good one. That's a good one. That's really true. Who else wants to introduce yourself? So you guys can be feeling the attendance. If you feel the attendance, you can react. All right, cool. So yeah, we'll get more familiar with ourselves on the Discord channel, and it was really nice to take you guys on today's breakout session. You guys will be seeing me more often, and I'm pretty excited to be on this journey with you guys. So yeah, meet you at the top.